Chapter 3. In the previous classes, we have studied the basics of acids, bases and salts. In the chapter The Acid-Base Chemistry, we shall study about these substances in detail. Acids and bases. Dear students, you must have enjoyed a variety of mouth-watering ingredients to relish your taste buds since your childhood. Recall the taste of some more ingredients given in the table. Table alongside shows the taste of some items found in your kitchen. In Latin, acidus means sour. Substances which are sour to taste have acidic ingredients and their solutions are acids. Substances which are bitter to taste are bases. What is meant by indicators? You must have observed that the traffic on busy roads of cities is controlled at various squares by traffic signals. Each of the three colors of the signal indicates the activity expected from the people, that is, to stop, to be ready, and to go. The acidic and basic nature of the compounds can also be indicated by some natural as well as chemical substances. These are known as indicators. You have studied in the previous classes that litmus papers help in detecting the acidic and basic nature of the given compound. Acids turn blue litmus red, whereas bases turn red litmus blue. Litmus paper or solution is obtained from a plant named lichen of division Thallophyta. Let us perform one activity. Prepare the extract of red rose petals, turmeric, beetroot and indigo. Keep the extract in 4 watch glasses. Cut small strips of white paper. Dip the strips in each extract several times. Dry them thoroughly. Then take 5 small china dishes with 5 solutions of lemon juice, common salt, baking soda, vinegar and edible oil. Dip 1 strip in each solution and note the change in color. There are many natural substances such as rose petals, turmeric, beetroot, etc. that can be used as indicators. They are called natural indicators. Let us do this activity. Collect samples of vinegar, lime juice, NH4OH, ammonium hydroxide, and hydrochloric acid. Note your observations when you add 1 drop of phenolphthalein, methyl orange, and put a litmus paper into it. Tabulate the result in the table. Some chemical substances such as phenolphthalein, methyl orange, eosin are also indicators. They are synthetic indicators. Look at this activity. Take a few drops of eucalyptus or nilgiri oil, eau de cologne, in 2 test tubes each. To one of the test tubes, add dilute HCl and to the other, add dilute NaOH. Shake the test tube well and check the odor. You can choose some more substances with typical odor and analyze them. There are certain substances whose odor changes in acidic or basic medium. These substances are known as olfactory indicators. Mixture of several indicators is known as universal indicator. Let us perform this activity. Collect samples of kokum extract, palak extract, any aerated drink, tomato juice, dilute HNO3, dilute KOH, prepared tea, ginger with honey and buttermilk in test tubes and add 2 drops of universal indicator to each. Note change in color and also pH. You have already learnt that acids contain hydrogen ions and bases contain hydroxyl ions. Can you quantitatively find the amount of these ions in a solution? From this, can you judge how strong an acid or base can be? Strength of acids and bases. You can judge acidity or basicity by using a universal indicator which shows different colors in different concentrations of hydrogen ions in a solution. pH scale helps in measuring hydrogen ion concentration in solutions. In pH, P stands for potens, which means strength in German. The scale reads from 0, meaning most acidic, to 14, meaning most basic. The value of pH indicates acidic or basic nature of a solution. The strength of base is represented by pOH. When the pH value is between 0 to 7, the solution is acidic in nature. At value 7, the solution is neutral, and between 7 to 14, the nature of the solution becomes alkaline or basic. When acids in aqueous give more number of H+ ions, then they are termed as strong acids. Similarly, when acids in aqueous give less number of H+ ions, then they are termed as weak acids. Is there any member in your family who suffers from acidity? What are its symptoms? Do you know why it happens? Do you know some household remedies to cure acidity? Many suffer from acidity. Symptoms are pain in stomach, burning sensation in food pipe. Baking soda in water is a cure. Milk of magnesia, that is magnesium hydroxide, is also a cure. Lime water with butter having butyric acid can cure acidity. Can you explain why? Based on the principle of solubility, like dissolves like, acidity can be controlled by acidic substance mixed with basic substance. Similarly, jaggery is used with tamarind while cooking. This helps in maintaining pH of our body. Importance of pH in and around you. Let us try out this activity. Collect sample of rainwater. Add few drops of universal indicator to it. Note the color change and also pH. What is the nature of rainwater? Color of water is yellowish green, which indicates that pH is 5.6. The nature of rainwater is acidic. When the pH of rainwater is less than 7, the rainwater is acidic. When it flows in a river, it lowers the pH of river water. Aquatic life is drastically affected due to acidic nature. Not only that, when this type of rainwater is absorbed by plants, it affects their growth, the flowers and fruits they bear, etc. The human body works within pH range of 7.35 to 7.45. Have you ever tried this activity? Collect your own saliva sample in the morning before you brush your teeth. Collect one more sample and test its pH with universal indicator after you brush. What will happen if pH is below 5.5? When the pH level lowers below 5.5, the acid level in the mouth is strong enough to attack the enamel and corrode it. You all know that tooth enamel is made up of hard matter, calcium phosphate. Food particles are degraded by bacteria in the mouth. With pH below 6, they corrode the phosphates to cause tooth decay. Activity. Collect various soil samples. Mix it with water and filter. Collect the filtrate in test tubes and test with universal indicator. Make a list of plants growing in that area. If paper shows orange color, pH of soil is 4, the soil is acidic. If color of paper is greenish to blue, pH is between 8 to 9 and the soil is alkaline. Hydrochloric acid produced in the stomach helps in digestion of food. The acidity or indigestion problems can be controlled by adding basic substances called antacids. Do you know red ants are known as phorma in Greek? When you are stung by a red ant, it causes itching and irritation. This is due to the acidic sting by red ants known as formic acid. Honey bee sting also causes a burning sensation. Let us look at the acids, bases and their reactivity. Reactivity with metals. Activity. Take a boiling test tube. Choose proper stopper through which you can fix gas passing tube. Take a few pieces of magnesium ribbon. Add dilute HCl to it. Take burning candle near the gas passing tube. What do you observe now? It burns with a pop sound. Repeat the same experiment with zinc and copper granules using other acids such as dilute H2SO4, dilute HNO3 and CH3COOH. All metals react with acid to give metal salt and hydrogen gas. Zinc forms zinc chloride and copper forms copper nitrate, and hydrogen gas is liberated. What will you observe when iron nails are treated with concentrated HCl? Iron combines with HCl to form iron chloride and hydrogen gas is liberated. The bubbles given out during the reaction are of hydrogen gas. Hydrogen is displaced by the active metal from the acid. Metal combines with remaining part of the acid and forms compound called salt. You can represent reaction as acid plus metal gives salt plus hydrogen gas. You can now have a balanced chemical reaction for the reaction between zinc and dilute HCl. Zn plus 2HCl gives ZnCl2 plus H2. Let us perform this activity. Take few pieces of aluminium ribbon in a test tube, add 3 milliliters of sodium hydroxide to the test tube and warm. Observe. Repeat the process with magnesium metal. Aluminium plus sodium hydroxide gives sodium aluminate. Magnesium does not react with sodium hydroxide. Write the balanced reaction between zinc and sodium hydroxide. 2NaOH aqueous plus Zn solid gives Na2ZnO2 aqueous plus H2 gas. Will you observe the same reaction with all metals? All metals do not react with bases to form salt and hydrogen gas. Reactivity of acids towards carbonates and bicarbonates of metals. Activity. Take 2 grams of aluminium carbonate in a boiling test tube. Add dilute HCl to it. Do not allow the gas to escape. Through the delivery tube, allow the gas to pass through decanted solution of chalk with H2O. What are your observations? The chalk solution turns milky. When metal carbonate reacts with acid, it forms corresponding salt CO2 and H2O. CO2, when passed through lime water, turns lime water milky. Chalk powder in H2O can be used instead of lime water. What will happen if baking soda is treated with dilute HCl? If baking soda is treated with HCl, it forms sodium chloride and carbon dioxide gas and water. Will you be able to give a balanced equation? Balanced equation is given as NaHCO3 plus HCl gives NaCl plus CO2 plus H2O. Now let us see how acids react with metallic oxides. Let us do this activity. Take a small amount of red oxide, primer used before paint. Add to it few drops of dilute HCl. What do you observe? What is the chemical formula of red oxide? The solution turns blue. Chemical formula of red oxide is CuO. You will observe that the color of the solution becomes blue. This is due to the formation of chloride of copper. You can represent the reaction as metal oxide plus acid gives salt plus water. CuO plus 2HCl gives CuCl2 plus H2O. Metal oxides do not react with alkali because there is no hydrogen ion which can be displaced by the active metal from the acid. Now let us look at the reactivity of base with non-metallic oxides. You have learnt before that calcium hydroxide is basic in nature. Carbon dioxide is a non-metallic oxide. Calcium carbonate is a salt and water is the product. Let us see how acids and bases react with each other. You have learnt in the previous lesson about the reaction of acid and base forming salt and water. You can perform the following activity under your teacher's supervision. Activity 3. Take about 3 milliliters of dilute HCl in a boiling test tube. Add to it 2 drops of phenolphthalein as indicator. Note the color. It remains colorless. Add NaOH solution drop by drop to the test tube. Is there any change in color? Solution turns pink. Why do you think the color has changed? Phenolphthalein turns pink in base. NaOH is a base. If you add dilute HCl to the solution, will you be able to note any color change? It becomes colorless again. Effect of acid is neutralized by base and vice versa. This is indicated by phenolphthalein, the indicator. The chemical reaction taking place can be represented as HCl aqueous plus NaOH aqueous gives NaCl aqueous plus H2O. The reaction between acid and base to form salt and water is termed as neutralization. Reactivity of base with non-metallic oxide is also a neutralization reaction. Do you know all bases do not dissolve in water? The base that dissolves in water is known as alkali. They are soapy to touch, bitter to taste, and corrosive. Acids are sour in taste and they too are corrosive. Do not touch or taste them. They cause harm. Ionization in acids and bases. Activity. Take 25 milliliters of sugar solution in 100 ml beaker. Dip 2 carbon electrodes. Connect the electrodes to 2 terminals of 6-volt battery through a bulb and switch. What do you observe? The bulb does not glow. If you repeat the same experiment with dilute HCl, methyl alcohol, dilute H2SO4, what will happen? The bulb glows in HCl and H2SO4 but does not glow in methyl alcohol. Glowing of the bulb indicated flow of electric current through the solution. Bulb will not glow in case of glucose and methyl alcohol because the electric current is carried through the solutions in the form of ions. You can now repeat activity using calcium hydroxide, sodium hydroxide, etc. What will be your conclusion from the result of the experiment? The bulb will glow as bases dissolved in water splits into ions and conducts electricity. Let us perform this activity. Take 0.5 gram of copper chloride salt in a test tube. Add to it a few drops of concentrated H2SO4. Test the gas evolved with wet and dry litmus papers. Which state, wet or dry, will show change in color with litmus? What precautions will need to be taken in humid condition? Dry litmus paper does not change its color. Wet litmus changes from blue to red. In humid conditions, the HCl gas gains moisture from air and ionizes, so precaution should be taken to keep gas dry. Separation of HCl into H+ and Cl- ions will be possible in presence of water. The process is termed as ionization. Hydrogen ions cannot exist alone. They will always combine with water and form hydronium ion. H3O plus H plus H2O gives H3O+. Base like NaOH, when dissolved in H2O, undergoes reaction as follows. NaOH solid plus H2O aqueous gives Na plus aqueous plus OH minus aqueous. Which ions do they generate? They generate Na plus and OH minus ions. You have learnt that acids generate H plus, that is, hydrogen ions, and bases generate OH minus, that is, hydroxyl ions in aqueous medium. Therefore, the perfect reaction for neutralization can be viewed as acid plus base gives salt plus water. Ha plus BOH gives Ba plus H2O. A is equal to an ion as in Cl minus, Br minus, I minus, NO3 minus, etc. B is equal to cation as Na plus, K plus, Ca plus plus, etc. The H plus ions of acid and OH minus ions of alkali react with each other to form unionized water. More about salts. You have learnt about the formation of various types of salts. Students, prepare saturated solutions to these salts. Add 2 drops of universal indicator to it. Note the observations. It is possible to identify the acids and bases from which these salts are obtained. When the pH value for the salt is 7, then it is considered to be a neutral salt. Salt of strong acid and weak base are acidic with pH value less than 7. Let us learn about common salt, NaCl. You have learnt that strong acid HCl and strong base NaOH react together to form salt sodium chloride, that is NaCl. Impure sodium chloride is brown in color and is known as rock salt, while purified sodium chloride is colorless, crystalline ionic compound. It is the fundamental ionic compound used in the preparation of other salts as Na2CO3, NaHCO3, etc. Electrolysis of NaCl in solution and infused state yield different products. When electricity is passed through solution of sodium chloride, which is termed as brine, 10% NaCl, it decomposes to form sodium hydroxide, an important basic compound. Chlorine gas is liberated at anode and hydrogen gas at cathode respectively. Salt, when heated at high temperature, the molten state is termed as fused state. NaCl is able to conduct electricity even in fused state. During electrolysis, chlorine gas is liberated at anode and sodium is deposited at cathode. Let us learn about sodium bicarbonate. You all enjoy tasty cakes, is it not? Have you ever tried to find out from a baker what is added to the cake to make it so spongy while baking? Have you ever taken trouble to ask your mother why the pakoras she makes are so crispy? The white amorphous powdered soda is termed as baking soda. Its chemical name is sodium hydrogen carbonate or sodium bicarbonate, and its formula is NaHCO3. When tested with litmus, NaHCO3 turns red litmus blue, which indicates that it is alkaline in nature. When heated strongly, it decomposes as follows. Sodium bicarbonate is extensively used in day-to-day life. It is used to prepare light and spongy bread, cakes, and dhokla. It also helps to reduce acidity in stomach, being alkaline. It is very useful in preparing CO2 gas and is one of the contents of fire extinguishers. Bleaching powder. It is the white powder which is generally sprinkled to disinfect any place which is not clean and is also used to disinfect water. You must have experienced the typical strong odor from well water during the rainy season. The white powder is called bleaching powder, and the strong odor is due to chlorine gas which is released when bleaching powder is added to water. When dry slaked lime reacts with chlorine gas, it forms bleaching powder. When bleaching powder comes in contact with atmospheric carbon dioxide gas, CaCO3 solid and Cl2 gas is released. This chlorine gas helps in the bleaching action on cotton in the textile industry, wood pulp in paper factories, and washed clothes in laundry. Bleaching powder acts as an oxidizing agent in many chemical reactions and is useful in the preparation of organic solvent chloroform, which is also used as an anesthetic. Bleaching powder is also known as chloride of lime, and the chlorine generated is known as available chlorine. The bleaching powder brands available in the market are classified on the basis of percentage of available chlorine present in them. Let us learn about sodium carbonate, that is, washing soda. Sodium bicarbonate is a white crystalline solid readily soluble in water. Sodium bicarbonate on decomposition forms sodium carbonate, whose formula is Na2CO3 10H2O. When tested with litmus paper, it turns red litmus blue, indicating it is basic in nature. When sodium carbonate reacts with HCl, carbon dioxide is evolved. Washing soda is used in washing clothes as a cleansing agent. It is very useful in manufacturing detergent powder, paper, and glass. It is also used to refine petroleum. Do you know presence of chlorides and sulfates of calcium and magnesium make water hard? Na2CO3 plays a very important role to make it soft and potable. Let us see what is meant by water of crystallization. Activity. Take few crystals of copper sulfate in a boiling test tube. Heat the test tube. What is the color of copper sulfate after you heat it? What else do you observe on side of the test tube? The copper sulfate turns white. There are drops of water on the sides of the test tube. The droplets of water you observe on the sides of the test tube are known as water of crystallization. They are the fixed number of water molecules present in the crystal structure. On heating or on exposure to air, salts lose water of crystallization and turn into a substance which is termed as anhydrous substance. What will happen if you add water to anhydrous CuSO4 in the above activity? Now you would be able to understand why we write the formula Na2CO3 10H2O. Soap as salt. When oils or fats are boiled with aqueous solution of sodium or potassium hydroxide, then sodium or potassium salt of carboxylic acids are obtained. These salts are known as soap. The process of alkaline hydrolysis of oils or fats is known as saponification. Well, that ends the chapter. Hope it was a joyful learning. You have the options to view a mind map for a quick recap and a question and answer section to study the exercises. Wish you all the best. Bye till we meet again.